Greetings, wherever you're watching from. My name is Ikenna Onyekwelu. I'm here to present my poster titled Modeling and Performance Evaluation of Photosynthetic Active Radiation, known as PAR, using satellite-based data, application to CROPGRO model. PAR is the component of shortwave irradiance in visible spectral region, so which drives plant growth and biomass production. Green vegetation utilizes power via photosynthesis to produce chemical energy required for growth and development. So an important input to crop model, which is the power we are talking about. However, they are not usually measured just like other standard climate variables, which poses a challenge to the acquisition. So this led us to the objective to study and evaluate the use of satellite-based data for estimating power in Eastern Cancer River Basin, and also to study the impact of PAR estimation on soybean yield simulations using this CROPGRO model. So we have a series of methodology that we follow to achieve our objective. So one of them is first we acquire satellite-based series power products from 1984 to 2013 from NASA Power for the two counties of interest, which were Riley and Shawnee counties. Then climate variables like minimum temperature, maximum temperature, relative humidity, dew point temperature, and clearness index, and also solar radiation. We are also acquired from NASA Power and Kansas Mesonet for power modeling. So we use linear modeling approach to achieve our power models by fitting, or what is sometimes called model calibration. So in that sense, we use 80% of the data for model calibration or fitting, and 20% of the data for model validation and evaluation. So for each county, we built 12 regressions from model 1 to 12 in series. So these models have different combinations of climate variables in explaining the interaction between power and these variables. And also after that, we went further to calibrate our DSAP model to ensure that our DSAP model will be able to reproduce our observed yield in the field. So you can see here the structural model diagram of DSAT. So the output from the DSAT model, which is the yield of interest, are being compared to the USDA NAS yield, and also in turn also being compared with the yield estimated from the best power model for this present study. So now looking at the results, so we, first of all, we calibrated the model as I mentioned earlier. So we can see that the calibration of the DSAT model reproduced the observation in the field. So, telling us that our model can be able to, simulate, yield in that region, in the region of interest. So looking at the figure 3 here, so you can see that figure A is for Riley County, while figure B is for Shawnee County. So these are regression fits for each power model. So after testing all the models with different statistical metrics, so we found that model 8 is the best power model for Riley County, and also the same for Shawnee County. So you can see how model 8 in Riley County, fits into a regression line of a tapered list, and also the same thing happens for Shawnee County. So we went further to use the model now, model 8 now, to estimate power that will supply to DSAT to estimate yield. But we know that DSAT in itself has default power values converted from solar radiation data fed into the DSAT. So we treated that one as default. So we want to see how the default power in the DSAT will be able to estimate yield compared to NAS, and also how our model built with series power products from NASA Power will be able to estimate power. At the end of the day, we'll compare the results. So, looking at the two results here, so you can see A is for Riley County, B is for Shawnee. So we found that the yield from model 8 matches very closely to the NAS yield than the DSAT default. But they are not statistically significant, meaning that, the two yields, are very close in terms of their means are very close. So what it means, so in conclusion, so we say that power data set from NASA Power can serve as, robust input to crop models and other biophysical models for estimation of yield and biomass. Also, we found that DSAT, CROPGRO model can reasonably reproduce a USDA massive, which is a very good thing for, for the region of interest. And also very important, was that the power model developed for this study can be used to estimate power in absence of ground observation. Thank you very much.